Video notes for chapter 8.4. Today we're going to take a look at a couple of proportionality theorems. So some unique instances that create proportional segments. The first one, our first learning target I should say, is we're going to be able to use these theorems to find lengths in triangles and transversals. And then our second learning target is to be able to find lengths when an array bisects an angle of a triangle. All right, our first proportionality theorem is for a triangle, and it says if a line parallel to one side of a triangle intersects the other two sides, then it's going to divide that triangle proportionally. So here's an example. You've got triangle RQS, and you can see the segment TU is coming through, and it's going to cut through the two sides of the triangle RQ and RS, and it's going to do so in such a way that it creates this proportion. This yellow segment from R to T is going to be proportional with, I'm going to create this pink one here, and then I'm going to create another pink one. Here we go. I'm just going to highlight these in different colors. Oops. And then we'll talk about it. All right, there we go. All right, so here's what we got. We've got these yellow segments here. R to T is going to be over this pink segment TQ, and that's going to be proportional to the other segment RU over that pink segment US. So if we I just highlight those guys in pink, we'll be all set here. So there we go. We've got yellow over pink is proportional to yellow over pink. All right, so there's our first proportionality theorem. That's if a line comes through so that it's parallel to that third side of the triangle. It's going to cut those two sides up proportionally. Now the converse of that says if a line divides the two sides of a triangle proportionally, then it's going to be parallel to that third side. In other words, if we knew yellow over pink was proportional to yellow over pink, then we could make the statement that TU must be parallel to QS. All right, in our next theorem here, it says the three parallel lines theorem. It says if three parallel lines intersect two transversals, then they divide the transversals proportionally. So you can see R, S, and T are parallel to each other. They got the little arrows here. And what that's going to do, because they're all parallel, they're going to create these segments. So UW is going to be proportional with its next one over here, WY, and that's going to be proportional to VX over the next little segment between the next pair of parallel lines, XZ. So I'm just going to change those colors here, and we'll do our same little color coding that we did on the previous one. So UW over WY is going to be equal to VX over XZ. Now I'm going to highlight this one here in yellow. All right, so now we've got our pink over yellow is proportional to pink over yellow. All right, so just keep in mind though, those segments here that the parallel lines create are in proportion to one another. Let's jump into examples and see how some of these theorems work here. So let's find the length of segment AB. So segment AB is this entire segment out here. And I can see that's formed by adding AD and DB together, and DB is our unknown amount. I can also tell that there's these two parallel lines. In other words, ED comes through triangle ABC so that it's parallel to that third side, which means I'm going to form these proportions. All right, I'm going to have these proportional segments. X over 3 should be proportional to 15 over 5. All right, that just comes from our first theorem up here at the top, the triangle proportionality theorem. All right, x over 3 is equal to 15 over 5. Now we're going to take our cross product here. We get 45 is equal to 5x. When we divide off that 5, we're going to get an x value of 9. Now that's equal to the length of DB. In order to answer the question AB, I got to add that 3 to it. So AB should be equal to 9 plus 3, which is 12. In example 2, they want us to determine if QR is in fact parallel to ST. So here's the question, Q to R, is that actually parallel with ST? And our way of telling this is to determine if these segments here formed by this line QR coming through the triangle PST are going to divide it up proportionally. So we want to write up a proportion. 35.2 over 8 should be proportional to 22 over the other segment there, which is 5. All right, now how do we tell if these are the same ratio? What we're going to do is we are going to take that cross product, 8 times 22, and see if it is equal to 5 times 35.2. That is our question here. In fact, it is. It's both going to come out to be equal 176. And because they're equal to each other, we know that this is a true proportion, and we can say now by the converse. All right, here's that converse theorem right up here. The converse of the triangle proportionality theorem. All right, we'll abbreviate that. Triangle proportionality theorem. We know that our QR is going to be parallel to ST. All right, let's flip the page over. Let's go to the back side of our notes. And here's our second learning target. This is talking about how an angle bisector creates proportional segments within a triangle. And this is called the triangle angle bisector theorem. If a ray bisects an angle of a triangle, then it will divide the opposite side into segments whose lengths are proportional to the lengths of the other two sides. So you can see here that we've got this ray CD, and it's coming through and it's creating two congruent angles here, right? It's bisecting angle C. And what this theorem is saying is it is creating these two segments, AD and DB. And those guys are going to be in proportion to their sides, AC and BC. So I'm going to say AD and DB here. Actually, I'm going to color code this differently. I'm going to do CA. So we have all one side in yellow highlight. Sorry about that. And then we're going to do a pink highlight in the other side there. Okay. Whoops. There we go. DB over BC. All right. Now we're cooking. So we've got AD, this segment here that this angle bisector is creating on this third side of the triangle is in proportion with DB, the other side, and then CA, the side of that triangle, is in proportion to the other side, CB. All right. Let's put that to a practice here in this next example. Example 3 says use a diagram to find the value of Z, and you can see here that Z is this segment VW, which is formed by this ray YW here that passes through and creates this angle bisector. Okay, so we know Z is going to be in proportion to, here's Z, this other segment that it creates, which is 10, and we're going to set that equal to the length of that side that Z touches, which is 52, over the length of the other side here, which is 13. All right, now we're going to simply take our cross product. That's 520 now is equal to 13Z. Divide off 13, and you're going to find that Z is equal to 40. Example number 4 says find the length of HJ. Here is our transversals proportionality theorem. And you can see that we've got these 3 parallel lines because they're all perpendicular to the same line. Remember, these are all corresponding angles. And so we're forming these proportional segments here. So we got segment HJ is going to be in proportion with 12. So we're just going to call segment HJ, we're going to call that X. X over 12 is equal to, and now we're going to set up our other proportion over here, which is 3 over the larger one, 18. All right, finding our cross product, that's 18x equals 3 times 12, which is 36, and x will be equal to 2. So HJ is equal to 2. All right, one more example problem for today, guys. The diagram here shows a triangle such that the length of LP is 9 less than twice the length of PN. So we're going to call PN here, this length x. It is 9 less than twice that, so PL is 2x minus 9. Now it looks like together we know they add up to equal 45. So that's 3x minus 9 gives me 45 if I want to find the length of LP and PN. So that's what we're going to do. We're going to add 9 over. 3x now is equal to 54. Divide 54 by 3, and x will have the value of 18. Okay, so PN is equal to 18. I'm going to label that right here. And then PL, the remaining amount there, is 45 minus 18. And that's going to give me, whoa, what is that? 30. I got it. It's 27. Just kidding. 27. So we'll label that guy 27. Just double checking my math there. Yeah, we're good. All right, next up. It says if ML is 36, here's 36 from M to L. We want to now find the length of NM. So let's call the length of NM Y here because we already used X. And here is, you can see this angle bisector up here. So M through P, this is that triangle angle bisector proportionality theorem, which says these two segments, right, will be in proportion. So 18 over 27 will be in proportion with the sides Y and 36. So Y over 36. Now we'll take our cross product here. It gives us 27y equals 18 times 36. In the end, we're going to divide that by 27, and y will end up being 24. All right, guys, that wraps up our notes for today. On to our book problems.